Pluto is a small world, far out on the edge of the solar system. It is so distant that it receives little energy from the sun. Temperatures on Pluto average about 40 Kelvin. In Fahrenheit, that's 388 degrees below zero. In July 2015, the New Horizons spacecraft reached Pluto. For the first time in history, we could examine this tiny world, and the results have been spectacular. Before New Horizons arrived, our best photographs of Pluto weren't very good. But we did know that Pluto is small, that it isn't very dense, and it has a large moon named Charon, along with a few smaller moons. Based on these facts, secular scientists were confident that Pluto would be a cold, inactive world. For a world to be hot, there are three primary sources of heat: radioactive decay, tidal heating, and primordial heat. And according to secular models, Pluto shouldn't have any of these. First, Pluto cannot have much radioactive decay going on inside. Radioactive elements are heavy, but Pluto is not very dense. Therefore, it's mostly composed of lighter elements, and not many radioactive elements. So, there's very little heat being generated by radioactive decay. Second, Pluto does not experience tidal heating. Pluto is in tidal equilibrium with Charon, so there's no heat energy coming from this source either. That leaves primordial heat, the heat left over from Pluto's formation. But small objects lose heat very quickly, and Pluto is a tiny little world. Secular scientists believe that Pluto formed 4.5 billion years ago. If this were true, Pluto would have cooled off and lost all its primordial heat eons ago. Therefore, if Pluto were billions of years old, it should have no leftover heat today, and no new sources of heating either. Pluto should be old, cold, and dead. And before New Horizons arrived, that's what secular scientists expected to find. But that's not what the spacecraft found. When New Horizons began sending back photos, secular scientists were shocked. Pluto is not old, cold, and dead. It is a dynamic, geologically active place. Large sections of Pluto's surface are smooth and craterless. These regions are very young, because there hasn't been enough time for craters to form in them. As one project scientist said, "This is one of the youngest surfaces we've ever seen in the solar system." How young are these regions? Recent studies have calculated that their maximum age is 500,000 years. That's only 0.01% of the 4.5 billion years that Pluto is supposed to be. But even 500,000 is not the true age. That's the maximum age of these regions. So in reality, they could be much younger than that. In fact, as one scientist admitted, this could be only a week old, for all we know. Apparently, Pluto is resurfacing itself. It appears that this is happening by convection. Warm material is rising up from underneath in a process similar to a lava lamp. This was a huge surprise. As Alan Stern, the New Horizons principal investigator, said, "Sputnik Planum," that's the region where the convection is happening, "is one of the most amazing geological discoveries in 50-plus years of planetary exploration." And National Geographic commented, "It's a geologically rapid process that scientists didn't exactly expect to see on a small, freezing world that lives, on average, 40 times farther from the Sun than Earth." But what's the energy source for this convection? How can Pluto still be geologically active after billions of years? It shouldn't be. As Alan Stern said, finding that Pluto is geologically active after 4.5 billion years, there's not big enough typeface to write that in. It's unbelievable. The young surface units on Pluto present a puzzle regarding the energy sources that power such resurfacing over timescales of billions of years. We've already seen that radioactive decay cannot explain this, nor can tidal heating. The only reasonable explanation for Pluto's geological activity is primordial heat, left over from its formation. But that can only last for a short time. It can't last for billions of years. Pluto appears quite young. There are other indications of geological activity in youth. Pluto has mountain ranges, with some peaks reaching 11,000 feet high, similar in size to the Rocky Mountains. But these mountains are a mystery to scientists who believe in a long age for the solar system. First of all, They were formed recently. As one article said, the prominent mountains at the western margin of SP and the strange multi-kilometer high mound features to the south are both young geologically and presumably composed of relatively strong water ice-based geological materials. Their origin and what drove their formation so late in solar system history remain uncertain. What process formed these mountains? They are mostly made of frozen water, but at Pluto's temperature, water ice is as hard as rock. After billions of years, what would be the source of energy for thrusting all this material upwards, thousands of feet above the surface? Elsewhere on Pluto, there are glaciers made of frozen nitrogen. These appear to be young and actively flowing. As one article said, no one dared imagine such a thick and localized buildup of geologically young ices that even at 40 kelvins have enough viscosity to create local landforms. And there were other surprises too. These interesting features here have been named snakeskin terrain. In other locations, hundreds of dunes have been observed, but these dunes aren't made of sand, they're made of frozen methane. The dunes appear to be young. As an article in Nature said, hundreds of methane dunes nestle at the base of Pluto's mountains. The formations offer a surprise on a body with such a thin atmosphere. Until now, some researchers thought that Pluto's atmosphere, which is at 1/100,000th the pressure of Earth's, could not support winds strong enough to sculpt dunes. But the team's analysis shows otherwise. The dunes probably formed in the past 500,000 years, which means Pluto is a geologically active world. Again, 500,000 years is a maximum age, not an absolute age. At most, these dunes are probably only a few thousand years old. Maybe they're still being sculpted today. Elsewhere in the Plutonian system, there were more surprises. Since 1978, it's been known that Pluto has a large moon, now named Charon. This is a very unusual moon. In the entire solar system, it's the largest moon compared to the size of the world that it's orbiting. Secular planet formation scenarios cannot explain how such a large moon could form around such a small world. So the usual answer is that an asteroid hit Pluto early in its history and formed a cloud of debris from which Charon formed. But New Horizons revealed a number of mysteries about Charon. For scientists who believe in billions of years, it has some of the same problems that Pluto does. Much of its surface looks young, and there appears to be recent geological activity. As a NASA article said, mission scientists are surprised by the apparent lack of craters on Charon. Relatively few craters are visible, indicating a relatively young surface that has been reshaped by geologic activity. And as this article acknowledged, that Charon is so geologically complex, however, would seem to require a heat source for reshaping what would have otherwise been a heavily cratered surface. But from a secular perspective, geological activity on Charon makes no sense. Charon is much smaller than Pluto. Its volume is only 13% that of Pluto's. If Pluto should have cooled off long ago, how much more should Charon have done so? Yet apparently, it still contains leftover heat from its creation. If that was billions of years ago, this is a problem. But if that creation took place just thousands of years ago, then it's not surprising. Along with Charon, Pluto has 4 other moons: Styx, Nix, Kerberos, and Hydra. These moons are very strange. Nix tumbles chaotically. When New Horizons flew by, this moon was rotating backwards, relative to its orbit around Pluto. Kerberos rotates sideways. Hydra rotates sideways too, and very quickly. It spins once every 10 hours. Why are these moons like this? Some scientists want to explain all 5 moons, including Charon, as being the result of a giant collision. However, if they had all formed from a collision, they would all be made of roughly the same material, but the 4 smaller moons have different compositions than Pluto and Charon. And all 5 moons orbit Pluto in circular orbits, closely aligned with Pluto's equator. Their orbits around Pluto are more circular than Earth's orbit around the Sun. A collision wouldn't be expected to produce these orbits. Also, a collision would produce a lot of debris and also some smaller moons, but New Horizons didn't find any. Lastly, the moons look young. They are very bright, especially Nix and Hydra, but this brightness wouldn't last for long. As one article said, how such bright surfaces can be maintained on Nix and Hydra over billions of years is puzzling, given that a variety of external processes, e.g. radiation darkening, transfer of darker material from Charon via impacts with dark Kuiper Belt meteorites, etc., would each tend to darken and redden the surfaces of these satellites over time. Before New Horizons arrived, many predictions were made about what we would find on Pluto. The secular predictions, based on billions of years, were wrong in almost every possible way. What did we find instead on Pluto? As one article said, it's more dynamic and alive than Mars. The only planet that has more complex geology is the Earth. Pluto is a delightfully bizarre world, with a fascinating system of moons. It was first discovered in 1930, so for almost 6,000 years of history, no human even knew it existed. But it was out there the entire time, quietly waiting to be explored. A wonderful little system, consistent with the biblical account of creation.